Hi my dear friends, this is Rashekar from our SAIMEDHA coaching center. Today we are going to discuss our remaining set of questions from previous KPTCL JE question paper. Right? Are you ready? You have to give the answers, okay? So you have to give the answers with me, right? Right, sir. So I am explaining here previous JE videos, previous JE question papers like that. And if you want full classes, please contact these numbers which are scrolling here for online and for offline. We started JE coaching as well as AE coaching in online as well as offline. And for more details, online nothing but daily 4 hours of classes. Morning 6 to 8, evening 7 to 9, live classes. JE as well as AE for both the people separately. For AE separately, for JE separately, morning 6 to 8, evening 7 to 9, 4 hours per day. For JE 4 hours, for AE 4 hours, classes are going on for online. For offline, in our Bangalore, Sheshadripuram, first main road, Sheshadripuram first main road, beside the HDFC Bank. Beside the HDFC Bank, Arihant Chambers. That is our premises. We are going to start live, like offline classes from this Saturday onwards. If anyone interested, for more details, call to these numbers, and for online and offline, you can come here. You will have a best knowledge from this, right? So let's start the answers and questions. See here the first question. Actually, this is from power systems. What is that? Skin effect. What is the skin effect? Generally, the skin effect nothing but it is the phenomena where the electric current flows away from the skin of the conductor. Is it? Go for next option. It is the phenomenon where the electric current flows mainly at the skin of the conductor. This is nothing but the skin effect. Skin effect nothing but generally the current which flows at the skin. For example, this is my current. The current may not flows in the middle of the conductor. Total current concentrated at the skin or at this corners. That is called skin effect. This is very important, sir, in power system. Our chairman, Dr.G.Ramana sir, ex-Transco ADE, he will deal this power system. You will get direct questions from SAR class. 25 years of experience. Right? Okay? You know about this. This is the first question. Let's go for second question. Yeah, this is the question. Let's see here. What is the mutual inductance? What he want? Mutual inductance. When the coupling coefficient 0.4 and individual inductances of two coils are like this. Here two coils are there. One is the 20 Henry and other one is the 45 Henry, and in between these two the coupling factor or coupling coefficient 0.4. Then he wants the mutual inductance. What is the formula for mutual inductance? Very important, sir. The formula M is equals to K into square root L1 L2. M is the mutual inductance. L1 is the self-inductance of first coil. L2 is the self-inductance of second coil. So from this, the mutual inductance M is equals to K. What is K here? 0.4. 0.4 can be written as 4 by 10. 0.4 can be written as 4 by 10 because here point after point 1 value is there. That's why 0.4 can be 4 by 10. So K is equals to 4 by 10 square root of L1. What is L1? The first coil inductance 20 multiplied with L2 45. So what is the answer for this? M is equals to 4 by 10 square root of, this is 900. This is 900. Yes, square root of 900. Square root of 900 is the 30. Yes or no, guys? 30 multiplied with 30. 2 zeros, 3 threes are 9, like this. So square root of 900 can be written as square root of 30 into 30. 130, one root cancelled. So square root of 900 means 30. So M is equals to 4 by 10 into 30. 0, 0 gets cancelled. 4 3s are 12. 12 Henries is our answer. 12 Henries is our answer. Very simple question. This formula is important, sir. They will ask you question on this formula even 2022 JE exam also. Remember this point. Right, sir? Let's go for next question. Let's go for next question. Yeah. Now tell me. What they given? What happens when the south pole of a bar magnet is but close to the north pole of a horseshoe magnet? What happens, sir? One south pole is there and this is bring near to the north pole. Then what will happen? If the south pole comes near to the north pole, then both are unlike poles. Unlike poles are attracts each other, right? We know, right? Right. So they attracts each other is the correct answer. Very simple. If both are same, like a south pole, then these two are repel each other. But these are unlike poles, that's why both are attracts each other. They attracts each other, that is our answer. Is it clear? Right, sir. Let's go for next one. Yeah. This is very important, sir. What is the question? Retentivity is also known as. To know this answer, we have to go for BH curve. This is the flux density and this is the magnetic field intensity. Initially, for example, if I am using sinusoidal supply like this, initially when this is also we can take it as current also, no problem. When the current is increasing, nothing but this is magnetizing. Then after magnetizing up to this, then after demagnetizing, but this is demagnetizing in this way, it is not supposed to go to zero. Why it is not go to zero? Even though the current is zero, the flux density is not zero. This phenomenon is called retentivity. Retain. This is not zero. Something is there. Of course, not 100%. This is the 100%. Not 100% is there. Just a few things are there. Just something is there. Remaining is completed. But this is not exactly zero. For example, Bengaluru Royal Challengers team is there in IPL. In that, before action, many players left from that, but 3 or 4 members retained again. The board, the Bengaluru Royal Challenge, retained Mr. Perfect, our Kohli, and few men, yes or no guys, retain nothing but just keep it like that only. Not goes to zero. They left over around 15-20 members, but retain 3 to 4 members. Retain, this is called retentivity. This retentivity is also called residual flux. This is also called residual. Residual means Virat Kohli not supposed to go to any other team. Residual is there. He won't go to any other team. He has to be there. Okay, so not supposed to go there. This is also not supposed to go to 0. This is a what is called RF, nothing but residual flux or residual magnetism. It is called residual magnetism. Retentivity is also called residual flux or residual magnetism. Sir, how we can get 0 here? How we can get 0? By applying some extra force. By applying some extra force is called coercive force. If you apply coercive force, then it comes to 0. Nothing but here current 0. If you apply negative current, then it comes to 0. When it comes to 0, then after again magnetization in reverse direction. Magnetization in reverse direction like this up to maximum. Then after again demagnetization in reverse direction. Again it not supposed to go to 0 because of retentivity, because of residual flux. Again we have to apply coercive force, coercivity. This is called coercivity or coercive force. Then it comes to 0. Again another cycle like this. This is called BH curve. In this is called retentivity or residual flux. This is also called retentivity, residual flux. This is called coercivity, coercive force. This is also called coercivity or coercive force. Okay, BH curve. The area of BH curve will give hysteresis losses. This is also very important. Area of BH curve gives hysteresis losses. Okay, so now our answer is retained reluctance no, residual inductance no, residual magnetism is 100% correct answer. Right, sir? Let's go for next question. Which of the following, what is the question? Which of the following use the principle of hysteresis? Which of the following use the principle of hysteresis? Generally, the thermostat as well as latching relay, both will follow the hysteresis principle. Both will have the retained property, residual property. Okay, so both have the hysteresis principle like that. So both is the correct answer. Let's go for next question. Yeah, see this numerical. They given few numericals also in this. We have to concentrate on numericals also. It's very easy, sir. To do this problem, you may not be a mathematics teacher. Okay, even if you know the simple mathematics, simple calculations, you can get the answer. Let's see. What is the induced current? What is the induced current when a 275 resistor is connected to a coil and induced voltage of 220 volts? Induced voltage of 220 volts. So what they given? They given resistance of 275 ohms and induced voltage of 220 volts. Then what is the current they are asking? What is the current they are asking? Let's tell me what is the current. Current I is equals to V by R. V is the 220 upon 275. Then what is the answer? What is the answer, sir? Let's calculate. See here. See the calculations. So let's go for 5th table. So 5 4s are 20. Again 20 is there. 5 4s are 20. 5 5s are 25. Again 25. 5 5s are 25. Very simple. Yes or no, guys? So 11 4s are 11 5s are. So what is answer? 4 by 5. 4 by 5. 5 1 so 0 point. If you take 0 point, its value 40. So 5 8s are 40. So the answer is 0.8 amperes. Very simple question, sir. Like a questions they will ask you in our examination. Okay. So what is the answer, sir? Not 8. 0.8 amperes is the correct answer. 0.8 amperes is the correct answer. Right? Let's go for next question. Let's go for next question, the 7th question. See here. See here, sir. You have to give the answer now. You have to give the answer. What happens to the induced voltage? What happens to the induced voltage when a stationary conductor is inside a stationary magnetic field? Stationary conductor is inside a stationary magnetic field, then what happened to the induced voltage? If a stationary conductor placed in stationary magnetic field, what happens, sir? Options: it increases, it decreases, it doubles, it will be 0. Can you guess the answer? Can you guess the answer? Come on, give the options. Yeah, give the answers. And give the reason also. Give me in a chart here. Give in comments. And give the reason also. Why it is. So see, generally to produce the EMF, we need 3 things. One is the set of conductors. Second one is the magnetic flux. And third one is the relative motion. This is also very important. If you have a conductor, if you have a magnetic flux, there is no EMF will induce. If there is a relative motion, then only EMF will induce. This relative motion 2 types. One is the relative time variation. Other one is the relative space variation. In relative time variation, conductor stationary and the magnetic flux is AC magnetic flux. In relative space variation, conductors are rotating, nothing but dynamic conductors, and the magnetic flux or magnetic field is DC, which is called stationary magnetic field. If the conductors are rotating, dynamic nothing but rotating. If the conductors are rotating, then the flux is stationary. One is rotating, one is stationary. Then relative motion is there. Here conductor is stationary and the flux is rotating. One is rotating, one is stationary. Then relative motion is there. But what he says, stationary conductor, stationary magnetic field. If both are stationary, then what is the relative motion? If the relative motion is 0, then what is the EMF? EMF also 0. Yes or no, guys? So, relative motion is important. So, if there is no relative motion, there is no EMF will induced. So, what is the answer? Increases, decreases, not decreases, sir. So, doubles, it will be 0. 0 is the correct answer. Okay? So, relative time variation, nothing but stationary conductor. Conductor stationary in which machine? Yeah, conductor stationary in transformer. Transformer should given by AC supply or DC supply? AC supply or DC supply? We have to give AC supply. If you want a new transformer, you can give DC supply also. If you give DC supply, the primary winding gets burned out. You can bring a new transformer, right? Okay, so we have to give AC supply. Here, the conductors rotating and the DC magnetic flux, nothing but in generators. In generators, the conductors rotated by prime mover, but the field winding given by DC supply. Yes or no, guys? So the answer is this one. Okay, I think explanation is more and more, right? But this is important, sir. They may ask you any question from this screen. You have to know all these things. That's why I am giving you explanation. Okay, are you following or not? Very good, sir. Let's go for next question. Yeah, Lenz's law defines. What the Lenz's law will defines? What the Lenz's law will defines? Every effect will oppose its very cause. Effect and cause both are opposite to each other. Every effect will oppose its very cause. What he decided? The EMF, the statically induced EMF is equals to minus n into d phi by dt. This minus given by Lenz, Sir Lenz. What he said? Actually EMF produced by rate of change of flux. EMF produced by rate of change of flux linkages. But this EMF induced by this one, but this EMF opposes this rate of change of flux linkages. Yes or no? So from this, which of the following is correct answer? The magnitude of induced current in relation to the effect which produced it. Okay, see next one. The direction of induced current in relation to the effect which produced it. Actually the magnitude given by Faraday, but the direction given by Sir Lenz. Okay, right? So which is correct answer? Option B is the correct answer. Why not C? Direction and magnitude. Sorry sir, magnitude given by Faraday. Right? None of this. So which of the following is correct answer? Option B is the correct answer. Very, very important. Remember Lenz's law, Faraday's law and Fleming's law. From these laws, you will have a minimum 1 or 2 questions in your JEE examination. Sure, sir. Let's go for next question. Yeah. Tell me the answer. Do and tell me the answer. Give me the answer fast. Give me comment. What is the question? What is the magnetomotive force? What is the magnetomotive force when 5 amperes of current flows through a wire? 5 amperes of current flows through a wire with 25 tons. What they given? I want MMF. Current they given 5 amperes. Number of tons they given 25. Then tell me. MMF, what are the units for MMF? MMF formula is N into I. Because MMF units is I nothing but amperes, N nothing but tons. Ampere tons, N into I. What is N? N is the 25 and I is the 5. 25 5s are 25 4s are 100, 25 5s are 125. Yes or no, guys? So what is the answer? None of these. 125 ampere tons. There is no milli, sir. Don't confuse here. Here they given milliampere tons. That is wrong. Yes or no, guys? Right? So do you know what are the units? Another units for MMF? The another units for MMF is Gilberts. The another units of MMF is Gilberts or ampere tons. Both are same. Okay, let's go for next question. Yeah. What is there? What happened to magnetomotive force when reluctance increases? Actually, what happened to MMF when reluctance increases? They are asking that. Before MMF, EMF. What is EMF? EMF is equal to formula I into R. If R resistance increases, then automatically EMF also increases. As usually, EMF and here MMF. Electromotive force, magnetomotive force. Here current will flow, here flux will flow. Here resistance which oppose the current. Here reluctance, S or R, anyone. Okay, reluctance can be denoted by S or R. Okay, so I am taking S. So MMF is equal to phi into reluctance, for example, phi into reluctance. So if reluctance increases, then MMF also increases. Very simple question. Here if resistance increases, voltage increases. If reluctance increases, MMF increases. Very simple question, sir. Don't confuse. So which is correct answer? Increases is the correct answer. Like this, they will ask you questions in our KPTCL JE. Okay? Prepare well. For online and offline classes, please contact here. I will be there, and our chairman Dr.G.Ramana ex-Transco ADE sir is there. He will give you more clarity about remaining topics. Have a nice day. Prepare well. Don't waste your time. And we'll meet you on next video with the next set of numbers of questions. Thank you and wish you very all the best.